This is Nellie, the presynaptic nerve, and this is Nancy, the postsynaptic nerve. Their function is to receive, summarize, analyze, and transmit information. The dendrite and soma are where neurons receive information from other neurons. The information is integrated in the axon hillock and sent via action potentials through the axon to the axon terminal. The information is output at this terminal and received by receptor sites on the postsynaptic nerve. The problem is that Nellie has a message she needs to communicate with Nancy. The process of information transmission is made possible by our good friend, Allie, the action potential. Let me give you a little bit of background information about Allie. Allie's potential for action is dependent on the ions inside and outside of the cell. There are forces such as ion channels and gradients that are constantly at play. The sodium-potassium pump actively increases potential for action by pumping potassium into the cell and taking sodium out. This creates tension and an increase in potential. There are also three kinds of gates involved. Ligand gating requires a chemical activation to open the channel. A change in voltage triggers voltage gating to open, and mechanical gating is when a physical distortion allows ions to flow. These are all mechanisms that play an important role in keeping Allie moving along the neuron. When the membrane potential becomes positive, an action potential is stimulated. If the membrane potential reaches the threshold of about negative 50 MV, the cell depolarizes, meaning the charge of the cell becomes positive. This occurs when sodium channels open and the flow of positive sodium ions enter. The stimulations are an all-or-nothing response. Failed initiations occur when depolarization doesn't make it to the threshold line. However, if the threshold is met, then a full action potential is activated. Once the action potential reaches its peak of about 40 MV, sodium channels close and potassium channels open, allowing a negative charge to re-enter the cell. This quickly hyperpolarizes the cell, meaning it goes past the resting potential. This is called the refractory period. Here, the potassium channels close, which allows the cell to return to its resting potential. This process, although complex, has a short duration of about 1 millisecond. Allie must travel down the axon. Myelinated axons increase the speed of conduction. Saltatory conduction transfers information and regenerates the action potential at each node of Ranvier. The nodes of Ranvier have voltage-gated ion channels, which assist in the regeneration process. Allie travels down the axon until she arrives at the axon terminal, where synapse occurs. There are electrical and chemical synapses. Electrical synapses have two membranes close in region called the gap junction, which allows for rapid exchange of information. A chemical synapse has a synaptic cleft and receptors on the postsynaptic region. Allie is trying to get her message across a chemical synapse. Due to the positive change of voltage, calcium channels open and calcium ions flow into the axon terminal. These calcium ions bind to synaptic vesicles containing neurotransmitters. The vesicles release the neurotransmitters into the synaptic cleft through exocytosis, where the neurotransmitter vesicles attach to the cell membrane. The neurotransmitters then act as a ligand to open ligand-gated channels located on the postsynaptic nerve receptors. This type of receptor is called an ionotropic. Another type of receptor would be a metabotropic receptor that requires a binding site, separate channel, and a messenger to communicate between the two. The opening of these receptors allows sodium to flow into the postsynaptic nerve. This influx of sodium is how the nerve impulse is communicated. There are three ways that neurotransmitters are removed from the cleft. 1. Enzymes break them down. 2. Presynaptic nerves recycle the neurotransmitters. And 3. Glial cells recycle neurotransmitters. Information has arrived at Nancy. EPSP is generated by the influx of positive ions such as sodium. IPSP is generated by an influx of negative ions such as chloride. Neural integration is when all the EPSP and IPSP combine to generate an action potential. Temporal and spatial summation is the combination of information from neural firing multiple times, or if they receive information from different neurons at the same time. The more summation of information that happens, the more likely it is that a stimulation will reach its threshold to produce an action potential in the postsynaptic nerve. And just like that, Allie has finished her mission of traveling down Nellie, the presynaptic nerve, and delivering information to Nancy, the postsynaptic